All right, this is section 12.7, horizontal translation of functions. And so we have here first the parent function. So I'm going to go ahead and put our parent function up there. And so this is the parabola, or this is the parent graph of the parent function. But now, in the previous section, there's a couple of things that are different. If you look in the previous section, 12.6, we had something like this. We had something like x squared plus 3. Now look at the red g of x, the function of g of x. What do you notice is difference between that red function, the g of x, and this green function here? Well, hopefully you're noticing that they are adding 3 to both, but the addition of 3 is included with the x, and it's being squared. It's included in the square on that red function of g of x. Whereas simply here, this is just adding 3 to the function. This is including the square. The 3 is included in the square. So hopefully that you're seeing what is the difference here. All right. And so when you have a parent function and it's being added inside the grouping symbol or within the square, what you get is a horizontal translation. The other thing that I want you to notice is that before, in the previous sections, we were using the same x values, right? Well, here, when you're determining if you're wanting to plot real quick the x values, you want to find out where that vertex is. So it might help you if you're doing the plotting method that you know what is the 0 of the function, so that you can get the vertex. So if I had, for example, used this number, if I had used 0, which I didn't use over here, well, look what happens to this function. So I have g of x, right, when it's 0. That gives me 0 plus 3 quantity squared, which gives me 3 squared, which gives me 9. So if I had plugged in 0 here, I would have got 9. You see. So I would have got a higher number. And so basically you want to just start, if you can, find out where the vertex is and do either 1 or 2 numbers below, above, and below. And so that's what they've done here, because if I put in, if this is our equation, right, and I plug in a -3, that gives me 0 squared, which is 0, right? So I'm looking here and I'm saying, what's going to make this 0? Well, a -3. So that's what you want to determine first, -3, and then you want to use the points above -3, the x value above -3. So that would be -2 and -4. And so that's how I came up with these x values. All right, and then we plug in, we get our y values. Same thing here. In this case, -3 is what gave us the 0. But looking at the yellow, the h of x function, we have to put in a +3 in order to get a y that is 0. And notice that I've used the +2 and 4 above and below. So when you're plotting, if they ask you in your plot, and that's part of the process, it helps you in determining what numbers, values do you want to plug into x, because you want to make sure that you're getting the vertex. But since we're using the translation method, if you learn the translation method, then you don't have to plot these points. So here's what happens when we have the original parent function, which is graphed. Now I'm going to graph the g of x, the red function, g of x. And first of all, I'm going to put that vertex, and then I'm going to go ahead and plug in my graph. What do you notice happened here? Well, from the original parent function, this vertex shifted over 3 units, right? So this actually moved over 3 units. and it moved over to the left. Interesting. Why did it move to the left? When they were adding 3, why did they go left? Well, what you need to realize for your rules for your horizontal translation, that if this is a positive constant, it's going to shift left. If it is a negative constant with inside, it's going to shift right. So let's look at our yellow h of x function. There's the vertex, and then we do the graph, and notice it moved to the right 3 places. So this is a special note, something that you really want to know, that vertical translations, they move the signs with a constant, okay, with the sign of the constant. All right, so when we were moving things up and down, if it was a positive constant, it went up, right? A positive constant. It went down when it was a negative constant, right? But in our case here, since we're doing the horizontal, when it is a negative constant, okay, it's going to the right. When it is a positive constant inside, right, it is moving to the left. So the horizontal translation moves against the sign of the constant and moves the opposite direction. So that's real key to remember. All right, so when you see that this is negative, it's going to go to the right. When you see it's positive, it's going to go to the left. And it's shifting on the x-axis. Okay, so in your homework, it's going to tell you to graph. So it'll not give you a function like this. Graph g of x equals the quantity x minus 1 squared, right? And so hopefully you're using the worksheet doc that I gave you. And if you look at the top of the document, this minus 1 is the same thing as minus h. H tells you it's a horizontal shift, and that it's going to shift right or shift left. If you look at the bottom table on your rule sheet that I've given you, and you find where it says g of x, quantity x minus c, it says the parent function translates c units right. So let's go ahead and look where our parent function is. Here's our parent function, and it tells us it's going to move c units right. Well, in this case, c, right, is the negative 1, right? And so it is going to, and technically, well, it's going to then move to the right 1 unit. And we've done that. We've moved to the right 1 unit. We're going to move our whole parabola, and we have now graphed it, which is what it had asked you to do to graph it. If you wanted to plot your points, you would go ahead and start off, where's the vertex, right? This is the vertex. And then from there, you would determine 2 numbers above 1 and 2 numbers below to find the other points. All right. The other way to look at it, if you couldn't figure out where it's moving or transiting, you realize that what value is going to make this 0? Well, 1 is, right? Because 1 minus 1 is 0. So that is why your vertex then is 1, 0. But you should be able to look at it and, following your rules, realize that what have they done to the parent function, and use your chart, and it tells you that you're going to translate it c units to the right. Okay, which is what we did. We translated the vertex and the whole parabola c units to the right. All right, now they're asking you to graph the function of x where you have the quantity of x plus 3/2 being squared. And again, you need to realize that this is going to be what type of a translation? Well, it's going to be a horizontal shift, right? Because they're doing something with inside the parentheses that's being squared. So what they're doing here is they're adding this 3/2, but it's with inside the square. So you'll need to recognize that the first thing you're going to do is that the vertex of the parent function is going to shift 3/2 units, okay? Well, that's the same thing as 1 1/2 units. And since this is positive, then it's going to shift to the left, okay, the opposite direction. So you end up with -1 1/2, okay, 0 as the vertex. As you can see, I've graphed that there. And then you just slide your parabola over and you have your sketch of your function. Again, since the vertex this is the vertex, if you wanted to plot points, you could start with the vertex here and then plot the 2 points above and below this -3/2. So as you can see that has just shifted it to the left when they're adding. If you were to look at your chart on your worksheet that I've given you, you would look at the very, very bottom and you can see where it says g of x equals f times the quantity x plus c. Well, that's this scenario. And it tells you the parent function translates c units left. So that's how you would use your sheet. Now the parent function f of x equals x squared, you know the parabola vertex is 0, 0. We've been graphing the parent function several times, right? And then in section 12.5, hopefully you discovered that multiplying a number by the parent function did not change the vertex. So for example, if you multiplied it by -1, or you multiply the parent function by 3 or 1/2, it didn't change the vertex. The vertex was still 0, 0. So that didn't affect the vertex any. All that did was either stretch it or compress it, right? Well, when trying to determine the vertex point for a graph that has either a vertical and a horizontal translation, the following methods help you in determining the vertex. So if it's a vertical translation, you're going to use the constant term as the ordinate y. For example, vertical translation is when you're just adding or subtracting a constant. So if this is the scenario, then your vertex is going to be 0 and it's going to be the ordinate y. So that if it's 4, it's 4. If you had the function x squared minus 3, then your vertex is going to be 0, -3. That's simple, right? Now, if it's a horizontal translation, then you're going to change the sign of the constant term in the parentheses and write it as the abacus. That's the S. For example, if you have the function of x equals x minus 3, that's inside the parentheses, right? You're going to change, since this is a -3, you're going to make it a +3, and that becomes the x value of your vertex. But what happens when you have a function and it's doing both the vertical and the horizontal translations, and they're both occurring, right? So what are you going to do? Well, you're still going to look at the constant term that's inside the parentheses, and you're going to change the sign and make it an opposite, and that's still going to be your x value. And then when you're adding or subtracting on the outside, you're going to keep the same, becomes your ordinate, y. Okay, in other words, you don't have 0 anywhere anymore, right? And so we're going to now start graphing where you're doing several different translations. And so this is how you can determine the vertex. Also, I believe if you look on my worksheet I've given you, the way I always remember things, as far as transferring, I've given you this general function here, the function of x, minus where a and b are a constant, h, n, and k are numbers, right? The x is the only, this x is the only variable, right? The only variable that's in it, right? So I've given you that on the worksheet. So when you have this in any of these forms, just realize that the vertex is going to be the opposite, okay, of whatever this is. So if this is a negative h, this becomes a positive h. This is a positive h, it becomes a negative h, whatever that h is, okay? And then the constant is going to stay the same. So it's basically the hk values that we're looking at here. All right. Now, this here actually applied to all the others before. Let's look at it. Okay, so here we have the function of x equals x squared. Well, is there any number that is being added or subtracted on the outside? No. So you're going to assume that's 0. Is there any number that is being added inside the grouping symbol? No. So you're going to assume it's 0, right? So that's why that vertex is 0, 0. Same thing for that. Looky here. If this is x squared minus 3 that we're looking at right here, all right, then we know that this is going to be the hibiscus. But there isn't any number inside the parentheses, so we're assuming that it's 0. So this rule actually, this last rule actually applied to all of these above. It's just that when there wasn't anything written, it was 0. All right? Hopefully that helps. All right, so now they're asking us to graph the function of x where you have a negative 1 times the quantity of x plus 1 squared plus 2. So we've got several things going on here. They're multiplying by a negative 1. They're adding 1 with inside the grouping symbol, and then they're having an additional 2. So we've got 3 translations that are going to occur. We're kind of combining everything here. But from what I just shared with you in the earlier slide, we can look at this and already know what our final vertex is going to be. Because we have the addition of 1 inside, then we're going to end up with a negative 1. And since they're adding 2 on the outside of the parentheses, we're going to have 2 for our y value. So that is going to be our vertex. So let's see if that is true as we begin to translate. So now looking at this, we have 3 different things going on, all right? Like I said, they're multiplying, they're adding 1 inside the grouping symbol, and then they're adding additional 2. Well, think of your order of operations, okay? Usually you solve what's inside the grouping symbol first, right? So I'm going to address in my first translation what is going on inside in the grouping symbol. What's going on there? Well, that's going to shift my vertex horizontally, right? It's going to shift it to the left 1 unit. So watch how I do that. I move my vertex to the left 1 unit, right? So there's my parabola so far. And then I'm going to do any multiplication or division. Well, right now they're multiplying by a negative or a negative 1. So you need to realize that's going to flip or reflect that upon the x-axis. And so there is your parabola. And then last, adding and subtracting. Well, they're adding a 2. That's going to be a vertical translation. So it's going to move up and down. Since it's positive, it's going to move up 2 units. So here's my vertex moving up 2 units. And then, so that's giving me that final vertex of a negative 1, 2. And there is your graph. So if you notice, by final vertex, I knew what my final vertex was going to be before I even started translating. And that's very helpful to know. And from there, if you wanted to plot points, you could. All right, just remember that you're going to start with your vertex, right, which is -1, and then you're going to do the two numbers above and below on either side of your vertex when you're plotting your graph. All right, so now they're wanting you to graph the function of x equals 2 times the quantity x minus 2 squared minus 3. Again, you've got some 3 different translations going on here. But we can start off by knowing what our final vertex is, right? Because this is a -2, we're going to make it the opposite and make it a +2. And this, we're going to keep the same sign for our y. And so there's our vertex. And it's always nice to know what is our vertex our final vertex before we even begin the translations, just in case we make a mistake. So again, we're going to consider what's inside the parentheses first. They're subtracting 2. That's giving us a horizontal translation that's going to move the vertex to the right 2 units. So that's what I've done there. And then they're multiplying by 2. Now, multiplying by 2, what that does is that moves all of the points not up 2 units, but double 2 units. They're doubling, right? They're going 2 times that amount, okay? So it's going to stretch it vertically by 2. So here's that graph stretch. So just to give you an example, in our original, this is at the 1 value here. If I look this direction, it's at the 1. If I take 1 times 2, so we're right here. Sorry, it's coming up 1, 2. All right. Now here, this is where? This is at the 4, right? So if I multiply 4 times 2, that shifts up here to the 8. This is where the 8 is, okay? So it's multiplying everything by 2, the y by 2. Not shifting by 2, but multiplying by 2. And that stretches that parabola and makes it narrower. And then last, we're going to subtract 3. That is going to be a vertical move that's going to move down 3 since it's a negative. So it's going to move that vertex down 3. So that stretched parabola then is just moved down 3 units. And notice our final vertex is still 2, -3. So the final vertex that we ended up with was the same. So that's it's always handy to know what is your final vertex going to be. So when you do your translations, you can make sure you haven't made any mistakes, right? Again, you can go ahead and graph, but you want to know what your vertex is. If you wanted to ask you to plot, then know what your vertex is, right? And since the x is 2 on the vertex, then you're going to use the x values that are 2 above and below. So if they are asking you to plot, figure out your vertex and figure out your points and plot. If they're asking you to do the translational form, then you're going to do the shifting. So I believe that is the last example for this section.